Welcome to Go Math, Unit 1, Lesson 2. Today we're going to be talking about prime factorization. So when we're talking about factors, these are numbers that can be multiplied together to form the original number. So for example, if we had a number like 10, we have numbers that can be multiplied together to make 10. We have 1 and 10, that's not really going to get us anywhere. We also have 2 and 5. So I would make what's known as a factor tree. So prime factorization, we're taking a factor tree and breaking down all the factors into the lowest possible prime numbers, numbers that can't be divided by anything other than 1 in themselves. And that will tell me the lowest numbers can be multiplied together to get this original number. So let's take something easy like 10. And I know that the factors of 10 are 1 and 10. I'll write them over here for you. Make a little factor rainbow, something that's going to come up again a little bit later this year. And 2 and 5. Those multiply together to get 10. Well, I can't do anything with 1 and 10. It's not going to change anything. I'm still going to have this 10 to break down. So if I break 10 down into two other numbers, being 2 and 5, and I would ask myself, okay, so can 2 be broken down into anything, or is it a prime number? Well, it can only be broken down into 2 and times 1. 5 is the same thing. There's not two numbers that are multiplying together, two whole numbers, excuse me, that are multiplying together to get us 5. So those are both prime numbers. So the prime factorization of 10 is 2 times 5. Well, what happens if I take a little bit more of a difficult number? The first one we're going to look at in our factor tree is 180. So we start with a basic idea. I know that 180 starts with 0, or I'm sorry, excuse me, ends with 0, so it breaks down into 10 plus another number. That's going to be 10 times 18. Okay, so let's get rid of the rest of this, and let's go back to that nice clean sheet, and we're going to show you that. So again, prime factorization of 180. Take two numbers that it breaks down into, and it really doesn't matter which two numbers you're choosing or which factors of 180. I separate them out, and I know because I looked at the other sheet, we're going to break this down into 10 and 18. Well, neither of those are prime numbers. They can both still be broken down into smaller factors. So we're going to do that. 10, as we saw originally, breaks down into two prime numbers, 2 and 5. And when I get to a prime number in a factor tree, I like to circle it. It just reminds me that I have a prime number here. 2 and 5, I'm done with 10. I don't have to do anything else. 18, let's break that down. Well, I could break it down into 2 and 9, or I could break it down into 3 and 6. Let's break it down into 2 and 9. Let's try that, because 2 and 9, because we can. I'm going to go ahead and grab 2 as a prime number, and I know 9 can be broken down yet again into 3 and 3, and both of those are prime numbers. So, prime factorization of 180 would be 2 times 2 times 3 times 3 times 5. I like to write them out from lowest to highest. So again, 2 times 2 times 3 times 3 times 5. And you might say, okay, well, where does this play in? Well, in real life, we use prime factorization when we're breaking down money, when we're breaking down time into manageable chunks. It really helps us take a larger number or a larger portion of something and break it up into smaller values. What would happen if I went back and tried this again and maybe erased this? Does it make a difference if I break this down into 2 and 9 or 3 and 6? So let's try that. I have 3 and I have 6. Well, 3 being a prime number, 6 is not a prime number. It needs broken down into 2 and 3. And what I'm left with again, 2 times 2 times 3 times 3 times 5. You can see that it doesn't matter which numbers or which factors I'm breaking it down into, it's still going to get me that same prime factorization. So again, prime is any number that can't be divided by anything but 1 in itself. Factors are numbers that are multiplied together to get a bigger number. So if we have a prime factorization, we use what's known as a factor tree, because it kind of looks like a Christmas tree here. So we have a factor tree, and we're breaking a larger number down into the smallest values that can be multiplied together to make that number. And it doesn't matter which numbers I'm choosing or which factors I decide to break it down into, whether this would be 2 and 9 or 3 and 6, they're going to come out the exact same. So my goal is to just keep breaking it down until I get prime numbers. So prime factorization helps us take larger numbers and break them down into small, manageable bits.